Hi everyone, welcome back. Naji here. In this video, we will be discussing on a most talked topic in generative AI, that is Retrieval Augmented Generation, which is simply RAG. So you probably may heard about something like use RAG or store your data in vector store or create embedding, something like that, right? So what does all actually means, right? So by the end of this video, we will be understanding what is why LLM need the RAG, okay, how embeddings actually works, and what happens behind the scenes when you ask a question, and finally we will build a complete architecture together. So let's start. So before we talk about RAG and AI and all those things, just think about a human scenario. Imagine someone hand over like a 2000 page PDF to you and asking, okay, you find out the answer for this particular question, and I am asking that, okay, give me the profit in 2025 or something like that. I'm just asking. So it is very hard to read the entire 2000 page PDF, right? So what we usually do, we will search for profit, and we will search for some keywords, right? Maybe like something like profit or 2025, and we will get then search will give us some pages. Then we will go through these pages, and we will figure out the answer, and we will tell that, okay, the profit is something like this, right? So that is what we do usually, right? So surprisingly, RAG also follow the same process. So we'll discuss how this works, but RAG is also will do the similar thing, right? If you ask some questions, it will search the document and it will retrieve the specific portion in the document, and it will try to answer to the question. Anyway, so just keep this in mind. Okay. Now, next is the context, right? So we know that the LLM have uh, trained with a lot of public data, maybe millions of public data, right? So, and it may be trained with maybe if I am training it today, okay, maybe it is January 1st, 2026, right? So I will be using all that public data available, and I will train the model, right? So what happens is that the LLM will not able to answer what happens after January 1st, 2026, right? So it does not have any idea. Its knowledge base is empty. So what we have to do, so whenever if we need to answer something after the 2026, like we have to pass some kind of a context, and we'll ask LLM to generate the answer from it, right? Or in some other scenario, if some private data information is there, so I have my own company is there, and I want to analyze its profit, its loss, and all those things, right? So if in that case also LLM does not have any information about my private database or private document, so I have to provide that to LLM to generate the data, right? So this is a second point that we have to remember. For example, I just created something in the okay, in the chat GPT. Here I'm just saying that, okay, give me details of XYZ animal. If you don't know, just say you don't know, and just use your knowledge base. Okay, then if I ask something like this, okay, XYZ, definitely there is no animal, something like that, right? Consider this is a kind of like a private database. Okay, so it says that I don't have any knowledge about XYZ animal. Now I says that, okay, XYZ animal is an animal with 4 legs and kill human for food, right? Use this as a knowledge base. Now I am giving some kind of a context to the LLM, okay, saying that, okay, there is a XYZ animal, and it has a 4 legs and it eat humans, right? And it has some context is there, and based on the context, I am asking a question like what XYZ eat, right? So it says that based on the knowledge base you provided, XYZ eat humans for food, right? So if you look on this, initially it does not have any idea about XYZ, right? But later I have given some kind of a context to the LLM, okay? Then based on that I am asking the question, right? So it's actually giving me answer based on the knowledge base. So knowledge base, building knowledge base is also very important. Okay, so we discuss two things here. One is we talk about how the human search work. Now we understand what is the importance of the context, right? Okay, so here what we just discussed, we will have a LLM engine, and we are providing the relevant context. Then that will create a proper answer. Okay. So now let's talk about embeddings, right? So what is an embedding? So this is very simple, right? Humans understand natural language, or maybe the words, we can simply say, right? But computers understand only the numbers. LLM models can understand only the numbers. So we need to have some kind of a translator which will convert our natural language into numbers, right? Something like that we can say. So that is what embeddings means. So if I say some human language words, and we will translate it, we will use the embeddings model to convert it, then we will convert that into some kind of a numbers, right? So one of the core important things that we have to remember, okay, so the similar words or similar sentences will be in the same region or same namespace, we can say, right? So for example, these three things, we can say that their meaning is almost similar. That's why they are coming, they are in the same namespace. Okay. So this is the second point that we need to remember. Okay. Now let's come to the RAG. So what is the RAG means? So RAG is, R stands for retrieve, A stands for augment, and G stands for generate. Okay. So retrieve means get the relevant data using exact or the similar search, similar to how humans does, right? Then augment. So augment means package the retrieved data and add the context to the prompt. Okay, so we are packing the retrieved data and add a question to the LLM. The generate is something like using this context, LLM will generate the answer. So that is why we are calling it as a RAG. Okay. So now just giving you a high level conceptual mapping. Okay. So in the human analogy, we are, if you ask something, what we are doing is that based on our example that we have discussed, we will use some index, or we will use some namespace, some keyword to search, right? So we will use our eyes to scan it, and based on the understanding, we will, our brain will process and will generate the result. So if you, similar to that, if you come to the RAG architecture, so we will have a database with some metadata information. So we will have a bunch of document, we will convert that into a database, right? Then we will use to search the relevant data, we will use embeddings and the similarity search. Okay. Then once we have the data, what we will do, we will give these details into the LLM, and LLM will generate it. Okay, in simple terms, we can say it. We can discuss more about this in our coming slides. Okay. So here, in a RAG, there are two steps are there. So one is the data injection part. Okay. Data injection part, and second one is the retriever part. Okay. So the injection part, it means we will take some document. Okay. For example, my my private company document will be there. Okay, I will create a knowledge base with respect to this document. Okay, so that is the first step that we will do. So similar to the example I have shown in the ChatGPT, I am giving some kind of a knowledge base, right? So similar to that, here I am creating some kind of a knowledge base, and the based on the knowledge base, we will able to retrieve the data, and we will generate the answers for that. So in the data injection process, okay, we can say that there will be 3 or 4 steps are there. Okay, so here, so we will have a raw data will be there. For example, my company information will be there, and we will do some kind of a cleanup there. So once we have done the cleanup, we will chunks the data. Okay, so for example, if you have like a 2000 pages of data is there, I cannot give like a 2000 entire 2000 page to the LLM due to various reason. Maybe we can say that it will hallucinate, or it will extend the context size, and all those things that we can say. So what we will do, we will break into small chunks. Okay, small pieces. Maybe simply I can say that, okay, I will split the document with respect to each paragraph. Okay, then once we have those things, we will convert that into the numbers. Okay, to convert that, we said that we will be using some translators, right? So here the embedding models are the real translators. So we will give some kind of a paragraph to the embedding model. So embedding model will convert that into some kind of a embeddings or numbers, and that will be stored into the vector database. So vector database are the databases which will help us to save this kind of a embeddings. There are a lot of vector databases are there. ChromaDB is there. Qdrant is there, PG vector is there, a lot of things are there. We can use any of these one, even in-memory vector store is also available. So this is our first step. So once we have the first step, then the second step is the retriever from the data. So for example, I am asking some query. Okay, I'm asking that, okay, give me the profit in 2025, right? So what it does is, this query will be converted into numbers, okay, or converted into the embeddings, okay. Then we will use some kind of a similarity search algorithms like cosine similarity to retrieve the similar content from the database. Okay, so maybe we will select 3 or 4 chunks from the database that talk about the profit, I mean 2005 company profit. Then we will pass this into the LLM, then LLM will generate the answer. So this is a simple retriever architecture. Okay, so you guys can relate this with how humans search in a big document, right? So then you will get a clear understanding about the retriever architecture. Okay, so in a high level, we will have 2 steps. One is the injection process, and second one is the retriever process. So in the injection process, I will have like a raw data will be there, chunk will be there, we will have embedding will be there, and we will insert into the vector database. Then the second step is a retriever process. Whenever a user asks some questions, okay, so we will translate that also into embedding. Then we will do some kind of a search in the vector database, and we will get some data, and that data will be passed to the LLM. Then LLM will generate the output. Okay. So next step is we can do some sample code by using this architecture. Okay. For that, I already have a Visual Studio Code. Okay, Visual Studio Code. Let me clear the this second. Okay, so here we have the data. Okay, so I have created 2. Let me close this. Okay, so here you guys can see there is a requirement.txt file is there, and I have a .env file is there where I have my OpenAI key is saved. Okay, now we have a as I said, there is a 2 step. One is the data injection step, and other is the retriever step. So in the data injection step, we can say that I am using the OpenAI embedding. So this is the translator which will convert our natural language into the embeddings. Okay. Now we will be using the loader. Okay, a document loader. Here we will be using the PyMove PDF loader. So which will help us to load the PDF, and it will read the PDF from our folder. Then next is we will use the splitter. Okay, so I said that the document will be converted into small chunks, right? So here we will be using the recursive character splitter. Okay, this is really good for splitting the document, right? So everything is provided by the LangChain, so it is very easy to use this. So let me execute this. Okay, now we have the loader, right? So I need to load this PDF. So this is the PDF annual report is the PDF. So let me open that PDF also. So here I can show you how this PDF will look like. Just a second. Okay, so if you look on this, okay, so this is the some publicly available details. I just copied that, or I just using this particular PDF, right? So this is the PDF that we are going to use. Here we can see that 364 pages are there. Okay. Now let me come here. Okay, I'm loading the details. Now let me load it into page by page. Sorry, let me load this, and I'm loading into pages. All right. Now here I can see that length of pages. Let's check for this one. Pages. Sorry. 10 pages. Here we can see 364 pages are there, and this actually split with respect to the page. Here we can see, let me take one page. Okay, so here we can see the details. Okay, anyway. So now next is I'm using the embedding. So I'm using the embedding from OpenAI. Currently I'm using test embedding 3 small. Okay, so how I will get these names? that is also, I can show you. You guys can go and check for OpenAI OpenAI developer document is there. We can see the models that is listed out here. Okay, so here I will be using the text model 3, text embedding 3 small, and there are a couple of other embedding models are there. Okay, large is there and ADA 002 is there. So this is very easy to use and simple and cost effective. That's why I selected this one. Okay, so let's do select this. Now I'm creating a embeddings. So embedding object, execute this, and we have the embedding objects. Okay. Now we are creating a splitter or recursive character splitter object. Let's execute here. Okay. And if you look on this, there are few things are there. We are setting the chunk size as 1000, and we are setting the overlap as 100, and we are putting the separators as //n, paragraph, and a new line and space, and the character, I can say simply. Okay, so what this means is I have to split out my chunks using 1000 characters. So first I will split with the paragraph. If paragraph is less than 1000, then we will keep that, and if it is more than 1000, then we will split with respect to /n until we reach the chunk size as 1000. So that is why it's called as a recursive character splitter. Then here we have another property, that the chunk overlap. So what is mean by chunk overlap? Okay, so if we have like 1000 characters there, then we will keep 100 character or 100 characters as 100 characters as a overlapping thing. Okay, so this will give us a context to the LLM. I will show you when we do the splitting process. Okay, now we have the splitter is there. Now I'm going to split these pages. So let's do that. Okay, so what I'm going to do, I'm going to show you like a chunk size, the 10th chunk. So if you look on here, we can see that some chunks metadata information is there, and we have the this. Let me scroll down. Here we can see the page content. So if you come to here, it is stopping by something like this, right? We cannot confidently predict the outcome of the current event and hour. Then it's splitting from here, right? And if you come to 11, the next chunk, here we can see there is a kind of a overlap will be there, right? So this thing, but we cannot confidently predict. Here also we can see, but we cannot confidently predict the outcome of the current event. So there is some kind of a overlap. So this will actually give a more context to the LLM. That is why we are doing the this kind of a overlapping. So this will give this final chunk 11 is from this is after this final chunk 10. That's kind of information that we will get. Okay, fine. Now next is we have this chunking is done. Now we need to create some kind of a vector database, and we need to inject this document into the vector database. Here we are going to use the Qdrant database that we are using. This is a really good database. Okay, vector database, I can specifically say. So I'm just importing the necessary details that is needed. Okay, so let me do that. So here we can see LangChain Qdrant is there, and I am importing the Qdrant vector stock. So here I'm creating the client. Since I'm using the local Qdrant client, like I don't need to specify the URL. Okay, so this is Docker images are available. You guys can just download and run the images. Okay, now once that is done, I need to get the vector size. Okay, so here what I'm to get the vector size, I'm just using I'm just running this. Okay, so let me print this. Okay, so this is the vector size of this particular model, and I will be passing this vector size when we create a collection. Okay, so the next step is I need to create a collection. Okay, or we can simply say that we have the Qdrant client is there. I need to create a database with respect to using I have to create a database in the Qdrant. So here we will say it as a collection, right? Since it is a like a similar to the MongoDB, we can call it as a collection. So here I am passing the collection name. So let me change it to something like UYT demo. Okay, and here I am passing some configuration, is vector size, and I'm saying that okay, distance is the cosine similarity. Now let's create the collection. So here we have the collection. Now I'm creating a vector store. So let me do a vector store based on this client and the embeddings. Okay. Now we have the vector store is ready. Now we will be adding documents. So we already have the final chunks with us. So we will be adding this final chunks to the Qdrant database. So before inserting that here, let me show you the Qdrant database. Okay. So let me run this. Here you guys can see there is a YT demo. So this is our database. And here we can see there is no document is there, right? So if you go to here, this is empty. Okay. Now what we are going to do, we are going to add this final function to the Qdrant DB. So let's execute this. So it's in progress. Let me go and search here. Okay. So let we'll wait to complete this. Okay. So it's in progress. Okay. May take some time. Okay, in between I can show you the data retriever part. So currently we have injected all the data into database or the Qdrant vector database. Now we are going to retrieve that. Okay, so if you remembering the retrieval part, okay, so we will have a question, and based on the question we will create an embedding, then we will do a similarity search, then we will give these details into the LLM, right? So that is what we are going to do. Okay. So I think the injection part is completed. The data injection part is completed. Let's go and check our vector store here. Vector store. Okay, still empty. What happened? YT demo. Okay, I show here I didn't change it here. So let me change it here. Let me do this. I have to change the collection name here also. So that's why it is empty here. So let me try it here. Okay, now we can see we are getting some data here, right? So if you look on this is the page content. Okay, then we will have some kind of a metadata information there. We can also customize our metadata information, and this is our second page content, and we can see everything here. So let me go back to the Visual Studio Code, and it is executing. Okay, now fine. Okay, let's continue this. Now we need to talk about the retriever. So retriever, I'm just importing the few things. Okay, hopefully you guys already have seen this import. I'm not going to explain this anymore. So here I'm creating the same using the same embedding model. So let's create the embedding models here. Now we need the one LLM model. So I'm using the GPT-4o mini. It is obsolete, but I'm going to use that. Okay, so this is our LLM, and I'm creating a Qdrant client. Now I'm connecting with my YT demo. This is my collection. I'm connecting my vector store to this particular collection. So we have the vector store. Now I'm converting this vector store into a retriever. So difference is the vector store is kind of a database, but retriever is kind of a runnables. Okay, so we need runnables to work with the LangChain. So that's why we are changing this into retriever. So let me convert this into retriever. So we have the retriever is there, right? Okay. Now let me. So I'm just skipping these two things. That is not necessary. Now what I'm going to do. So here we are creating a proper prompt for this one. So I'm saying that you are an assistant for question answering task. Use the following piece of retrieved context to answer the question. If you don't know the answer, just say that you don't know, and use 3 sentence maximum to keep the answer concise. So here I am passing the question, and I'm passing the context, right? And this is the answer, and I'm creating a prompt using this prompt, right? So let me update this. So here we can see a format document will be there. So this is actually doing some kind of a formatting, and I'm taking from the chunks, I'm taking only the page content. Okay, so what it mean is, let me go back here. If you look for a document, right? If you look for a document, here we can see lot of metadata information here. We don't need that. So what we are only focusing is the only the page content only. Okay, so that is why I'm creating some kind of a format document. Okay, I'm taking only the page content. So this will actually reduce the context size. Okay, now here I'm building a chain, RAG chain. Okay, so here you guys can see a question is there. Okay, we are using the runnable pass-through. So this runnable pass-through will not change the question. Question will be passed to the LLM as it is. Then based on this question, we will do some kind of a retriever, and we after that we will do some kind of a formatting of a document. Okay. So once we have the context and when we have the question, so here we have the question and the context, right? This will be passed to our prompt. Okay. So finally, the prompt will be passed to the LLM. The LLM will generate the response. The response will be passed to the output parser that will generate the result. So so let me create a chain. Now I'm asking, okay, what are the financial highlights of 2025? Okay, this is the question. I'm invoking with this question, and here we will have the response. Let's do that. Now we can see that this is the response. It says that in 2025, the total net revenue is like a 182,444 million. So let me go and check this is correct or not. So for that, I can go back here. Let's check here. It is correct, right? 184,444, that is correct. Then with a net income of 57,048. 57,048 seems to be correct, right? The net income per share is 20.05. I don't know from where it is there. Okay, so this is per share is there 20.05. That is also correct. And the cash divided. Okay, I think it's reasonably we are getting a good result. Okay, so let me ask another question. So let's see the global system in 2010 and 2025. That is also we are getting a reasonably good result for this one. Okay. So I hope this is clear. I will upload this into GitHub because I think it's a long video, so I don't want to extend it more. So basically, I hope the idea is clear, right? We are creating a data injections and we are retrieving the data, and we have related this this entire RAG system with how the humans does, right? So that's it. If you have any questions, please ask in the chat box. Comment box. I will try to answer that. So please do like and subscribe. Have a nice day. Bye. Thank you.